So we are saying when it comes to resolution of forces, you have, for example, a system of forces. Let me use this example, and let me use this example. Maybe I say this is F1, this is F2, and this is F3. F1 is at an angle of 90 degrees with the horizontal. This F2 is horizontal. Then this F3 is at an angle. Let me see if this is 120. So this becomes 210. 210, this would make this one maybe 150 degrees. Of course, for it to add up to 360. Now, to get the resultant, for example, of these forces by method of resolution, we are going to have it in that resultant is going to come from a resolution of these forces vertically, that is vertically and horizontally. So if it is vertically, we are going to look at the vertical components of those forces. And we already said that any force that is having a vertical component, that component is going to have a sign of the angle between that force and the horizontal or the reference point. So if in this example I take, let F2, let F2 be the reference. F2 be the reference. If F2 is the reference, that means I'm going to be considering uh, each of these forces with respect to F2. In other words, F1 will be having an angle of 90 degrees with F2, which is horizontal. In most cases, you pick an angle which is, a force which is horizontal, so that it becomes easier for you to determine the sine and cos components. So, the vertical components are going to be having a sine theta, or a sign of angle with which that force is going to be making with the horizontal. Then the horizontal components are going to be having a cos component. Okay, so we are going to start. When I look at F1, okay, let me start from F2. The vertical component of F2 is actually 0 because it is horizontal, and it therefore has no vertical component. But you can state it as vertical components the vertical component of the resultant is going to be the vertical components of each of the forces. Let me say it is equal to the vertical we shall say is equal to the sum of vertical components of all the forces. So now we begin with F2. So it will equal to F2 sine of the angle it makes with the horizontal, which is 0. When you look at F2, when we look at our F2 here, it makes an angle of 0 with the vertical, isn't it? It doesn't, you see, it is horizontal, so it makes an angle 0 with the vertical. So we shall write it as F2 sine 0. Then we go to F1. F1 makes an angle of 90 degrees with the horizontal. Therefore, we shall add F1 sine of 90 degrees plus F3. Now F3 is tricky. What angle does F3 make with horizontal? So you need to make to complete this horizontal line or extend it beyond this side, and you look for the angle that F3 makes with that horizontal line. So we said from here to there is 180 degrees. But we know that from here to here is 90 plus 120, which gives you 210 degrees. So I'm going to go to 210 degrees. I subtract 180, and that would give me 30 degrees. So, but of course, you need to consider it in terms of direction. Where is it pointing? All the vertical forces pointing upwards are going to be considered positive. Those pointing vertically downwards are going to be negative. You have to understand that. Otherwise, it is going to be difficult because you will find you're getting a wrong value. If we don't consider the directions in terms of vertically upwards or vertically downwards, I will also show you another method. But for this method, let us um, let us create a negative here because it is pointing vertically downwards. You have to master these principles very well. So if it is pointing down, the component here is going to be pointing vertically downwards. So that's why we are making it to be a negative. So it will be F sine, we said 30 degrees. We proceed. What is the horizontal component of the resultant? Horizontal component of the resultant, how are we going to get it? It is equal to sum of the horizontal components of all the forces, of all forces that form the resultant. So obviously, this is going to be now F2 cos 0. We see F2 again is parallel to the horizontal. Therefore, it makes no angle with the horizontal. So it will be F2 cos, because we said the horizontal component of any force is always going to be a cos. Yes, you have to understand that. So it will be F2 cos 0. What else? Now what is F1? F1 is vertically upwards because it makes an angle of 90 degrees with the horizontal. So that means it also doesn't have a horizontal component. And how we are going to take it, we will see that will be F1 cos 90. Because this cos 90 is equal to 0, and we will kill the F1. So it will not be there when you are calculating. But as time goes by, you master this and see that when you reach here, you even don't need to write it because you know it doesn't have. So you will only consider those that are at a particular angle greater than or less than 90. Then what about this? This F3 is also pointing this direction. So forces, horizontal forces pointing in the x positive x direction are positive. Horizontal forces pointing in the negative x direction of the Cartesian graph are negative. Therefore, when we reach here, on F3, we shall say minus F3 cos of the angle it makes with the horizontal, and that will be 30 degrees. So I started with maybe a complicated example, but if I give you now a one which has only two forces, you will be able to appreciate because you will do it very fast. So this would be cos 0 is equal to 1. So times F2, it will be F2 plus F1 times 0 because cos 90 is 0. That one goes away. So minus F3 cos 30. So F3 cos 30. So this will be F2 minus, what is cos 30? Cos 30, when you put it on a calculator, it is the same as sin 60. Sin 60 is equal to this cos 30 and is equal to root of 3 out of 2. So this will be root 3 out of 2 F3. And this will be in newtons. You need to also understand these angle ratios. But of course, as time goes by, you'll study them in mathematics and you'll be able to appreciate. Then, of course, sin 30 is equal to cos 60 and is equal to a half. So, or 0.5. When you press it on your calculator, you should be able to see that. So what is sin 0? Sin 0 is also equal to 0. So this will be 0 plus F1 sin 90. Sin 90 is equal to 1. So I will have F1 minus F3 sin 30. So I said sin 30 is a half, so I will have a half F3. And this is in newtons. So therefore, if I want to now produce my resultant, to draw the resultant and its components, if that is F, the resultant, then the vertical component is going to be, we said it is F1 minus F3. So this will be F1 minus F3 out of 2. This is in newtons. Then, of course, horizontal, we are saying it is equal to F2 minus, this is F2 minus root 3 out of 2, F3 newtons. And then I'll be able to get my F. Now, how do we get the direction after getting the direction and magnitude? So F, let me maybe make this A. Let this be represented by A. Okay, let me call it Y. Let me use Y. Let this be Y. Y newtons, and this is X newtons. So my resultant should also equal to Y squared plus X squared, everything out of root. I mean everything inside root. This comes from Pythagoras theorem. Then obviously the direction will be tan. If I call this alpha, it will be tan alpha equivalent to, now we look for a tan. A tan is opposite over adjacent. This will be y out of x. Y out of x. Y out of x. Of course, your alpha will be arctan y out of x. And that would give you a summary for getting a resultant by method of resolution if given a number of forces. Let us look at an example. We are going to look at an example that has two forces. So the first example that we had on our parallelogram was 100, and this was 150 newtons. So calculate, find the resultant, F. This is F. Now, by resolution or resolving forces. So we are going to resolve these forces vertically, resolve forces vertically. Now, remember, this angle was 45 degrees. It is 45 degrees, and I want to get the components of those forces. So the vertical component will be 100. Can you tell me the vertical component of this force? Is 100 sine 45 degrees. 100 sine 45 degrees. Now plus, why positive? Because it is pointing vertically upwards. Then plus the vertical component of 150. Since it is horizontal, the vertical component is going to be 0. But then we are going to put it as 150 sine 0. So plus 150 sine 0 degrees. Obviously, we said sine 0 is the same as 0. So 0 times 150, that will go. And this will be, sine 45 is the same as root of 2 out of 2. So this will be 100 root of 2 out of 2 plus 0. So for accuracy, I'm going to make this 50 because by 2, 1, by 2, 50. I'll make it root 50 root 2 newtons. Then I resolve forces. Horizontally. So if I resolve forces horizontally, that means 100 will take a cos 45. See? 100, the horizontal component of this force is as if you got this force and made it horizontal. So if it is made horizontal, then it will go through a cos of 45. So you get 100 times cos of 45. Then plus, because the horizontal component is positive, I've left it as positive. Then the other side will also be 150 cos 0 because it is horizontal and makes an angle 0 with the horizontal. So this will be, cos 45 is also root 2 out of 2. So it will be 100 root of 2 out of 2 plus 150. So what will that be? It will be 50 root of 2 plus 150. So maybe I can give a block value there, which will be 50 root of 2 plus 150. And this is giving me 220.71 newtons. What about the other one up? 50 root of 2. This gives us 70.71 newtons. How do you proceed? You come and redraw. You redraw the first diagram. This is the first diagram that shows the resultant. and its components. This is the first diagram of the resultant and components. So the one here vertically, we said this is 70.71 newtons. We have said this is 220.71 newtons. This angle, we don't know it, so we have to calculate for it. Now, this F, using the Pythagoras theorem, we said it is going to be y squared plus x squared, everything to power a half, or taken as a root. Power a half is the same as taking a root. So our F will equal to 70.71 squared plus 220.71 squared, everything under root. So F is equal to I square my 70.71 plus 220.71 squared. I take a root of everything, and my value is the same as 231.76 newtons. This is the same as 232 newtons as we had earlier on. As we had earlier seen. And finally, our tan alpha is equal to y out of x. Where does that come from? I said tan is equal to opposite. The opposite of this angle is y, and the adjacent is x. That's why I have adjacent, opposite of adjacent, and that is giving us y out of x. This is equal to, the y is 70.71 divided by 220.71. So what is alpha? Alpha is equal to arctan of 70.71 divided by 220.71, and would give you a value 70.71 divided by 220.71. So arctan of that answer would give you 17.764. So let me just write 17.76. So if you check on your value that we got up there, they are the same. Let's check using the parallelogram. So you can see this one, we can approximate it 232 newtons. I'm doing it like this because it's what we have in the book, but you can leave it as this. It's the same. Then the angle, we got it as 17.76. So we have solved the same problem using the method of parallelogram law of forces before, and now we have solved the same problem using resolution, method of resolving forces. So in summary, you need to break down the force. You break down those forces into the horizontal components and vertical components. So after getting the horizontal and vertical components, you use Pythagoras theorem to get the resultant. Y squared plus x squared, you take a root. Then you use tan ration, which is opposite of adjacent, and you'll be able to get your angle with which that force makes with the horizontal. And that's all.